To discuss properties of acids and bases, I'm going to just talk about reactions of acids, and that becomes their operational properties. And before I do that, I'm going to talk about the notion of salt formation, which is usually because of reactions of acids with other species. Now, the hydrogens within acids could be imagined as replaceable atoms, and if you replace it with another atom, you usually form salt. If you look at the example of nitric acid, it's monoprotic acid. It only has one hydrogen that can be replaced. What is the last name of the salt that you will form? Nitric acid becomes something nitrate. So if you replace hydrogen with sodium, which is group 1, you will form sodium nitrate, NaNO3. Now, sulfuric acid is diprotic. It has two hydrogens that can be replaced. And the last name, when it becomes a salt, is simply sulfate. If I replace it with potassium group 1, then I will have K2SO4, potassium sulfate. If you look at phosphoric acid, a weak acid, is triprotic. And this is the only acid with maximum number of hydrogen. You see 3 hydrogens that can be replaced. And if I replace it with, for example, then again, something such as magnesium, I'm going to give you phosphate as last name. And if you put magnesium now, you have to remember how to do ionic nomenclature. This becomes Mg3, PO4 goes inside parentheses twice. If you have forgotten, you have to refresh your mind and remember crisscrossing of the charges. So that's magnesium phosphate. Ethanoic acid is also monoprotic. It only has one hydrogen that is attached to oxygen that can be replaced. These hydrogens that are attached to carbon are extremely strongly covalently bonded, impossible to remove them. But this hydrogen can simply be replaced. If you put sodium, then you would form something of a sodium ethanoate. So ethanoic becomes ethanoate. And it is CH3COO, replace it with sodium, then you have sodium ethanoate. Many times we have tendency to show the charge of sodium for weak acids as the byproduct, and 1 minus for CH3COO minus. If you don't do it, it's not wrong. Now let's just talk about specific reactions of acids and bases. The first typical reaction is reactions of acids with metals, but the metals should be reactive, and they go by acronym MASIT. These are metals that react with dilute acids. M stands for magnesium, Mg. A is for aluminum, another reactive metal. Z is for zinc, Zn. I is not iodine, it's rather Fe, iron. And finally T is element tin, Sn. They can react with dilute acids. So if I take, for example, hydrochloric acid, HCl, aqueous, if you put solid, let's say magnesium into it, the magnesium is going to replace the hydrogen and you will form MgCl2. Then again, nomenclature and subscripts are important. Aqueous, and you are also going to release a gas which is hydrogen. And it's diatomic, so it's always H2 as a gas. Balance it, so put 2HCl. Now this is molecular reaction. Sometimes IB wants you to know the ionic and net ionic. So if you have ionic version, anything aqueous can split into ions. So HCl becomes 2 hydrogen plus aqueous, 2Cl minus or chlorides aqueous, plus Mg solid. Solids cannot become ions, they are as is. Aqueous here, so it's Mg2 plus, 2Cl minus, subscript comes up because they are separated and they are floating around. Gases cannot be separated, H2 gas. And simply this is ionic version of this reaction. But going back to what's important, acids react with metals to give you salt plus hydrogen gas. That's crucial to remember and be able to write the equation. So acid plus metal. Another typical reactions of acids is those reacting with carbonate or hydrogen carbonate. So if I take acid, this time if I take sulfuric acid, H2SO4, If we put it on something that is made out of marble, like calcium carbonate is marble or chalk, there is a reaction. Calcium is going to replace the hydrogen here and give you calcium sulfate. And then you produce H2CO3, which is carbonic acid. It's weak acid. And what happens, this weak acid has further decomposition in this fashion. H2CO3 will break into becoming liquid water, and bubbles of gas or carbon dioxide are going to be released. So overall, the reaction is usually written as this, or you have to be able to write it. So I'm taking the same reaction, calcium carbonate, and I'm going to give you calcium sulfate as is, but instead of writing carbonic acid, I'm going to give you water and carbon dioxide, CO2 gas. So then again, acids plus carbonate will give you salt, will produce water, will produce carbon dioxide gas. So this is another typical reactions of acids, which is actually harmful to environment. When you have acid precipitate, it reacts with marble statues and it breaks it apart. It affects seashells, eggshells, because they all have a shell made out of calcium carbonate. And we talk about that eventually. The final reactions of acids are reactions of acids with bases or alkalis. Now, bases are a generic term that include alkalis. Alkalis are bases that are soluble in water. If I take hydrochloric acid, HCl, metal oxides are also considered to be bases. So if I give you magnesium oxide, solid, this is a base, or is going to behave as base, therefore basic. It will give you a salt, MgCl2, plus the remainder is water, H2O, liquid. So acid plus base is salt plus water. Now this reaction has its own name and you are exposed to it. This is known as neutralization. It's important in chemistry, we talk about it a lot. Eventually I come back and we do a couple of titrations. Salt and water are being produced. One other thing you have to remember, it also produces heat. For 1 mole of water, you probably produce about 57 kilojoules of heat. If this is the case, neutralization is always exothermic. Another reaction as exothermic reaction that you have to remember. Now let me give you a base that is hydroxides. Hydroxides are good bases. If you take nitric acid, example number 2, put it with, let's say, potassium hydroxide. Now, potassium hydroxide is alkali. It's soluble in water. Not all bases are soluble or they're known as alkali. Now, I will give you a salt, so the salt should be nitrate, so it's KNO3. Potassium nitrate, this is your salt. And you should produce water, H2. What else do you produce? You should remember it's going to produce heat. Is it exo or endo? Since heat is being released, it is exo. So typical properties of acids is their reactions with alkalis or bases, with carbonate, and finally with metals.